So we will next do the FO4 delay. So for that I will show the circuit and the procedure. Okay, so we will first do it for GPDK180. So file new cell view and we'll call it FO4 and insert the circuit. Okay, so we have GPDK180 and then we need NMOS. Okay, and here itself we can change it. The total width of the NMOS in GPDK180 for FO4 is 400 nanometer. Okay, this is the minimum possible width. Let's say if we reduce the width, let's say I put 350 nanometer, it will say warning, total parameter 350N exceeds the lower limit of 400N. So you cannot go below 400N for the NMOS transistor and a PMOS transistor. Now since this is the minimum possible width, this is considered as a unit size transistor, that is size 1. Okay, so for this circuit we need a few of these, so we will put all of them together. I need 1 and I need 2, 3, 4, 5. These are all the loads, and similarly I need PMOS transistor also 5, and for that the total width is 800 nanometer. Okay, because it is a size 2. Our unit inverter is 2 and 1. Since 1 is 400 nanometer, 2 is 800 nanometer, and rest is the same. So here, here and here. Okay, and that's all the transistors we need. Next we need the other components like our VDC, etc. So I put DC 1.8 and I will put that in the top here. Okay, and I'll rotate that just to make it a little easier to create the circuit. And one wire, okay, let's undo that, from here to here, here to here, here to here, and then that gets connected to the VDC on top, and then rest all connections, the fourth terminal everywhere is connected to the arrow mark terminal, and the same for the bottom also. 2, 3, 4, and here and here. The connections here, inverter, 2 terminals connected, and okay, and bottom I need a ground. I can also use that for the, so I'll put one here and I'll put one here and I'll put one here. Okay, so then make the connections to the ground in the same way. And the connections here, you can use the same VDC, I don't need another one. And this becomes the input, this goes to the ground, and for the input of the first one I need a V pulse, and okay, so let's just check once. Everything is there. We have the 4 inverters and we have the inverter. Now the only thing is these inverters don't have the inputs, and that is where the FO4 circuit connection comes into the picture. This output is connected to all the 4 of the same, so you can connect from here to here, then you can take from this to this, then you can take from here to here, and finally this to this. So basically all the four are connected to this point. You can also check that by double clicking the wire. You see output given to this, it's given then to this, that's given to this, and finally to here. And this is our FO4 circuit. We give the input at this point and we observe the output at this point. What is the delay? That is the FO4 delay for GPDK 180. Okay, so I will launch. Transient analysis is fine, so 50 nanoseconds, and say okay. The outputs to be plotted. Select on design, input, output. Okay, then run. Okay, so I'll get the output. So generally I leave the first one or two inputs for the circuit to settle down. Then we put the marker, horizontal marker at 0.9, and more horizontal marker at okay, and then TPLH 35.0782 minus 35.015. That will be my TPLH. The next pulse I can calculate TPHL 40.0431 minus 40.005, and the average of those two numbers will give you the propagation delay for FO4 in GPDK 180. And next we will see how to do the same in GPDK 90.